When we have two sets of data which we think are correlated, then we can work out the correlation coefficient. Let's look at these two sets of data, and first of all we'll look at the scatter diagram between them to see if it looks like they're correlated. We go to Insert, we go to Scatter, top left gives us that, which looks like quite good correlation. Just move the graph down a bit, and let's see how we can actually numerically work out a measure of how well correlated they are. To do this we need three more columns of data. We need x times y, we need x squared, and we need y squared. So to find x times y, it's a formula, so we have equals the x value multiplied by the y value. In this case 1 times 4 equals 4, and we can click and drag that, go to the bottom right, left click, hold down and drag, and that will do the product for all 5 entries. Now we want x squared, so that equals the x entry A2 squared, which in our case is just 1 squared, and we can click and drag that to get all of them, and y squared similarly equals the first y value squared, which should be 16, and indeed is, and then we click and drag that. Now what we need from this are the totals of each column. We just move this down a little bit further. The way we get a total is by going to the first number in that column, dragging down and perhaps leaving a couple of rows at the bottom. We then go to Home and Sigma. That will add up a column, and it will give us 19 in this case. We do that for each of these. Home and Sigma will give the total. Home and Sigma for the total of xy. Home, Sigma for the total of x squared, and lastly Home and Sigma for the total of y squared. We then have a rather complicated formula to find the correlation coefficient, and it works as follows. Let's tuck it in here. Equals, now it's a quotient of one expression divided by another, so let's put the top one in a bracket. It's the average of all the xy's, so we have the total of the xy's. In our case there are 5 data points, so we need to divide by 5. Then we have to take away the average of x, which is the total of x divided by 5, times the average of y, so that's the total of y's divided by 5. That's the top of our fraction, and we divide then by the square root of a product, and the first item in the product is actually the variance of x, so that's the average of x squared. We take the total of all the x squares and divide by 5, minus the average of x squared, so brackets the total of x divided by 5 squared, and that gives us in fact the variance of x, and we now have to do the variance of y. So we want the total of y squared divided by 5, take away the mean of y squared. So I need a bracket first, bracket the total of y divided by 5, and I need to square that. That gives me the variance of y, another bracket to enclose the whole lot in the square root, and I enter that and I get 0.864, etc. That's a measure of how well correlated those two data sets are. It's very near +1, so it shows there's good positive correlation.